Hello, everybody. Welcome to today's lecture. So we're going to move on to chapter 5 today. So make sure you were good with the fraction section because now we're going to move on from fractions and we're going to move into decimals. Okay. So decimals work kind of similarly to fractions. In fact, we can represent any fraction as a decimal. Okay. Now the opposite is not true. We cannot necessarily represent every decimal number with a fraction. There are some numbers that have what we call infinite decimal expansions, which cannot be written as a fraction. These would be numbers like pi, for example, which you might have heard of, or some other numbers like the square root of 2, for example, or the square root of a lot of numbers. They can't be written as fractions, so we write them as decimals instead, but usually we're approximating in that case. So decimals have their uses. They really can represent more numbers than fractions can. Fractions are typically more exact though, so if we have a choice, we usually would prefer to use fractions. Okay, but nonetheless, decimals are used. Really, they're probably used more commonly than fractions are. If you go into any kind of like science in any kind of science class, they're typically using decimals instead of fractions. Any kind of like economics, any kind of statistics, they're typically always using decimals. Okay. And you probably use decimals a lot. Anytime you're dealing with money, right? With money, we use decimals to represent our money. We use 2 decimal places, in fact, to represent how many cents we have to every dollar, right? So let's first look at how we name decimals. Okay. So recall, first of all, if we have a number like this, for example, 5,037,896. This number right here was the ones place. This number was the tens place. This number was the hundreds place. This number was the thousands place. Okay. This number was the 10,000s place. Then we have the 100,000s place. And finally, this one was the millions place. And then we would just continue on in that fashion. The next, if we had another digit, it would be the 10 millions. The next digit would be the 100 millions. Then the next digit would be the billions, 10 billions, 100 billions, trillions, 10 trillions, 100 trillions, quadrillion, 10 trillion, 100 quadrillion, etc. Okay. So basically every 3 places we have a new name. And then for the next 2, we would put a 10 in front, put a 100 in front. Okay. Now these names aren't random. These names come from the fact that we could take this number 037 896. We did some simpler examples of this back all the way in 1.1, so it's okay if you don't remember this part. But I don't know if we did any with numbers this big, but this would be, we can write this as 5 times 1 million plus 0 times 100,000 plus 3 times 10,000 plus 7 times 1,000 plus 8 times 100 plus 9 times 10 plus 6 times 1. Okay. So this is where they get their names from. We have 6 ones, we have 9 tens, 8 hundreds, 7 thousands, etc. Okay, and we can write it like this. We don't typically write it like this, but this on the left here is really just a more compact way of writing this on the right. Okay. So that's how we named our whole numbers. So with decimals, we're going to do something similar. Okay. What we're going to do is we're going to add a what we call a decimal place, or just a decimal. Okay. And on the left side of the decimal will be the whole number part. Okay, so maybe we have 31 over here. Okay. This will be the whole number part. And then on the right of the decimal will be the, it's not a whole number. It's only part of a number. Okay, just like with fractions, if we had like a mixed number like 31 and 1/4, for example, we have the whole number part, the 31, and then the 1/4 is the fractional part, which only represents part of a quantity. Same exact thing with decimals. The 31 is the whole number part. The decimal part is going to be only a partial quantity. Okay. So if we have 31.25, for example, the 25 is the what we would call the decimal part. Okay. So this is the decimal part. So that's the part that doesn't represent a whole quantity. Okay, if I put a $sign in front of this, you might recognize the number, right? This is like having $31.25. Okay. So the 25, it means we don't have a whole dollar. We only have part of a dollar. We have, 25 cents out of 100, which would make another additional dollar. Okay. So 100 cents makes a dollar. And similarly here, the last decimal place is the 100th place. Okay. So in 31.25, the 2 here, that's what we call the 10ths place. And the 5 is what we call the 100ths place. Okay. So it's very similar to the names up here, the 10s and the 100s, but we have the TH on the end instead. So this should look kind of familiar. This is how we did fractions, right? If 2 is in the 10ths place, that's implying that we have 2 tenths. Okay, and that's exactly what it is doing. If 5 is in the 100ths place, that's saying that we have 5 hundredths. Okay. If we put these together to see how much do we have overall, well, we would just add them together. If we did that, we could convert the 2 over 10 to 20 over 100 by multiplying top and bottom by 100. And we would see overall we have 25 hundredths. Okay, which is what we would expect putting it into the money context, right? We have 25 out of the 100 cents we would need for another dollar. So typically, this last part is the only one we care about. We typically just look at the whole quantity here and put it over whatever the last place value is. So instead of doing 2 over 10, 5 over 100, we would just go straight to, okay, this is a 25. So we'd put it over 100 because the last place we have is a 100ths place. We don't have to do the addition because it always works out like this. If we, so this is what we do with money, right? We only have 2 decimal places, but we could have way more than that if we wanted to. Say we had 0.38765. It continues on just like the regular place values continue on in the same order. It's just we're going backwards. Okay. So the first one on the right side is the 10th place. This one is the 100ths place. This one is the thousandths place. This one is the 10,000ths place. And the last one here is the 100,000ths place. Okay. Okay. So, since we already learned about fractions, to really get a grasp of what these numbers are, it might be helpful to convert them into a fraction. And the way we convert decimals into fractions comes from the names. Okay. If we take, for example, this one, so let's say decimal to fractions. Okay. Oops. Okay. So because the last decimal place is the 100,000ths place, yeah, just want to make sure I was spelling that right. We take the decimal part and put it over 100,000. Okay. So we take the 38765 and we put that part over. We don't have a whole number part here, so we don't have to worry about that. But we put this part over 100,000. Okay. And that's how you convert from decimal to fraction. If we did have a whole number part, say if we had 21.38765, we would just leave the whole number part alone and we could write it as a mixed number. I should have a comma here. We leave the whole number part by itself on the end and we'd write it like a mixed number like this, and then we could convert it to an improper fraction if you would prefer, or if you need to do the math with it. Now, of course, this is a huge fraction. Like in terms of the numerator and the denominator, they're both huge, but you could reduce it if you want. Like, for example, you could take a 5 out of both the top and the bottom, right? If you take a 5 out of the top, you are left with 7753. And if you take a 5 out of the bottom, you are left with 20,000. Okay. I mean, you might be able to reduce this even more, but we'd have to spend some time looking for possible factors here, of which there would be a ton. So, going to decimal to fraction is just identifying what your place value is. Okay. So 31.25, for example, well, the 5 is in the hundreds place. So we would take the 25 and we'd put it over 100. Okay. And then if we wanted to, we could reduce that down to 1/4. Because you would take a 5 out of or you could take a 25 out of the top and the bottom. Okay. So this should make sense because, 31.25, that's like $31 and 1/4. And that's exactly what 1/4 means, right? It means 1/4. You need 4 quarters to make $1. Similarly, if we had 0.50, then we would take 50 and put it over 100. And we could reduce this down to 1/2 because you could take a 50 out of the top and then a 50 out of the bottom. Okay. So 0.50 is 1/2. This is like having 2 quarters, right? which would be half of $1. Now notice, if we just do 0.5 instead of 0.50, then we would get 5 over 10, which also reduces down to 1/2. So this implies that that extra 0 to the right of the 5 right here is not important, and it's not. We can put as many zeros as we want after the last digit, and it's not going to change anything because we could always just reduce it down just looking at this one. So this doesn't have any meaning. We can use that to our advantage later when we're doing when we're going the other way, fractions of decimals. So putting a 0 after the rightmost digit, it doesn't matter. You can put as many zeros as you want. Okay. 0.5 is the same thing as 0.50 is the same thing as 0.500000. Okay. It doesn't matter. Similarly, the 0 on the left side of the decimal here, that also doesn't matter, because notice it doesn't show up when we do the fraction part. So it's kind of just a matter of personal preference whether or not you actually write the 0. You can just as well write 0.5. I think it's better to write the 0 when we are handwriting it, especially because sometimes it can be difficult to tell if something is really a decimal or not, because it might just look like a random mark on the page if you do it quickly. So it's good to have that 0 there, just for clarity's sake, but it's not necessary. You can just write 0.5 or you can write 0.5 and it's the same thing. Okay. Okay. In the same way, if we write zeros on the left side of a whole number, okay, like 0, 3.1, we never do that. But if we did, it would not have any meaning different from just 3.1. So we could put as many zeros to the left side of a digit, of a whole number digit, as we wanted to. There's just not really any motivation to do that. But this one, there will be motivation for it, for when we go from a fraction to a decimal. Okay, let's look at that right now. So going from a fraction to a decimal, now we kind of do it similarly to how we converted fractions to mixed numbers. If you recall that, if we had something like 5/4, right? So recall, when we did 5/4, we did 5 divided by 4. So we do the long division, right? And then with our remainder, we take the remainder and we put it over the divisor as a fraction. So we'd have 1 1/4 for our mixed number. With the decimal, we start the same way. Okay, so we do 5 divided by 4, and we start by doing the long division. The difference is what we do when we get here. Okay, when we don't want it to be a mixed number, we want to convert this to a decimal. So what we do is we add a decimal place onto the 5, and we put a 0 to the right of it. We're allowed to do that because, like I just said up here, these are all the same thing. If we don't have a decimal place, we can just put as many zeros as we want. Right, 5.0, that would be like 5 0/10, which is just 5. So we're not changing what number this is. So we put that there. So now what we can do is, instead of dealing with that remainder, we can just keep the division going. We can bring that 0 down. Now, when we put a decimal place in the 5, we should also put a decimal place in our answer, okay? Because we're always lining up the place values. So now we're just going to keep going. We're going to say 4 goes into 10 how many times, which is 2. And then we have 2 left over. And we're just going to keep doing this until we get a 0 remainder or until the numbers start repeating. Okay. So we get, now 4 goes into 20, 5 times. 5 times 4 is 20. So we have a 0 remainder. Okay. So 5/4 is equal to 1.25 is what we find out from this. Okay. And we can clearly see going the other way, right? If we take the 2/5 and convert it to a decimal, we'd put the 2/5 over 100, which we already did before. We saw that it simplified to 1/4. So we would have 1 and 1/4, which is this part, which we already showed was equivalent to 5/4. Okay. So if we're going from a decimal to a fraction, if we have a whole number part, we're typically going from decimal to mixed number. Then from there, you can go to a regular improper fraction if you'd like to. If the problem doesn't ask you to go that far, that's fine. So for here, we just do the division, but instead of stopping when we run out of numbers, we just add more zeros on and keep going. Okay. Now, it doesn't always terminate like this. If we have something like 1/3, for example, well, let's do one more example first, actually, and then we'll go ahead and do, let's do like 3/8. And then after this, I'll look at one that repeats. Okay. So this one's a little bit weird because the top number is smaller than the bottom number, right? So we're doing 3 divided by 8, which is a little weird. But we can still do it the same way we would. 8 goes into 3 0 times, right? So now, instead of stopping here and saying 0 remainder 3 or 0 and 3/8, we would add a decimal place, which we should also put in the answer, add a 0, and then bring down the 0 and keep it going. So 8 goes into 33 times. Okay. So we get 6 left over. So now we just add another 0. 8 goes into 67 times. Subtract the 56. 8 goes into 45 times. And we get a 0 remainder now. Okay. So 3/8 is equal to 0.375. Okay. And if you do it in your calculator, if you just type in 3 divided by 8, you should get 0.375. Okay. Okay. Like I said, though, we don't always end up with a 0 remainder. The most common example of this is 1/3. So if we do 1 divided by 3, right, first that's bigger, so we're going to go, 3 goes into 1 0 times. And then we're going to start adding decimal places. Okay. So now we ask 3 goes into 10 how many times? Well, 3 times 3 is 9, so we have 1 left over. Okay. And now we bring another 0. But now we're asking the same question again. 3 goes into 10 how many times? So we're going to get the same answer. Okay. And if we keep doing this, we're just going to keep getting 3. And there's no way for this to change, right? So once we see that we're getting the same number over and over again and it's repeating, we can stop. Okay. So this is what we call 1/3 is equal to 0.333. So sometimes we might write 333 ... The ... implying that it's just going to keep going on this way forever. Or more commonly, because the ... It's not really great because it kind of might look like another decimal place, which doesn't make sense, we would write 0.3 with a bar over it. So the bar over it means it repeats forever. Okay. So yeah. Now, when this happens, this means if we tried to convert it the other way, it would be basically impossible, right? If I gave you the 0.3 repeating and asked you to turn it into a fraction, I mean, it would just not be possible unless you just already knew that it was 1/3, right? Because you're looking for the last decimal place and there would be no last decimal place, right? So that's not something I would ask you to do. Okay. Now, sometimes the numbers can go on for a long time before you realize that it's repeating. And it doesn't always have to be the whole decimal that's repeating. Sometimes you'll have a few digits and then it'll start repeating. Okay. So we'll look at an example of that. If a number starts repeating eventually, or if it terminates, if it ends, like the other ones did, that's how we know it can be represented as a fraction. But some numbers just never terminate and then never start repeating. That would be a number like pi. Okay. Let's look at 1/7. This one's a really long one, so I'll go through it. It'll take a minute to get through it. 7 goes into 1 0 times. Okay. So we add a decimal place. And now 7 goes into 10 one time. Right, and we got 3 left over. 7 goes into 30 4 times. 7 times 4 is 28. 7 goes into 20 2 times. So nothing's repeating still. Okay. 7 goes into 60. Was that 8 times? Okay. 7 goes into 40 5 times. Okay. 7 goes into 50 7 times. And now we see, okay, now we got this 1 back, which is what we had originally. So if I kept going, I would have 10 here, right? I would add a 0 and bring it down. And then I'd have 7 goes into that 1 time. And then this whole pattern would just repeat again, right? Until eventually I came back to 1. So once I start getting that same digit, we're done here, okay? So this whole thing is repeating. So here we would say 1/7 is equal to 0.142857 repeating. Okay. Now, you might notice something a little funny if you put it into your calculator. For example, on the Android phone here, if I do that, I get 0.1428571429. So different. Why am I getting that? Well, the calculator isn't going to go on forever. It's got to stop somewhere. So the calculator just cuts it off and it rounds the number. Okay. Similarly, if you just put in 1/3, it'll just give you a bunch of 3s, but it won't say that it goes on forever. If you do 2/3, 2/3 would be 0.666 repeating. The 6s would just go on forever. If you do in your calculator, though, the last digit is a 7 because, again, it's rounding. Whoops, sorry. So you got to be careful of that when doing it in a calculator. One thing maybe I should mention, which I mean really isn't too relevant to us, but if some other countries, instead of the period for the decimal place, they'll use a comma. So it might look weird to us, but I know some European countries will do that. So if you're ever reading anything from another country, you should be careful that a decimal place might be represented as a comma. You should look for the context in that case. Okay. Okay. Let me just make sure I didn't miss anything here. Now I think we're good. We basically did 5.1 and 5.3, I should mention, in case you're looking at the book. So I skipped over 5.2. We'll just come back to 5.2 next time. One little trick I want to mention before we go here, which will be relevant to us. Decimals. The name decimal, the prefix deci. Okay, deci means 10. Okay. So the decimal system is sometimes referred to as the base 10 system. A base 10 system means that for our numbers, we have 10 digits, right? We have 0 through 9. And then once we run out of numbers, we start repeating. We add a place value and start repeating the numbers. So 10 is really special to our number system. In fact, it's so special that if we take 10 and we multiply a number by it, we don't really even need to do the multiplication. All we need to do is move the decimal place. So this right here would give us 31. Okay. So multiplying by 10, we'll talk more in depth about decimal multiplication next time. I just want to mention this trick first. Multiplying by 10 moves the decimal to the right one time. Okay. So if we did 27.343 times 10, for example, we would take the decimal, move it right here, and we would get 273.43. Okay. So we don't actually need to do anything. All we have to do is move the decimal. If we took a number like 5 and multiplied by 10, remember 5 is the same thing as 5.0. So again, we can use that to our advantage because now we can just move the decimal over and we see we get 50. Okay. If you multiply by 100, that's like multiplying by 10 twice. So you would just move it over twice. Okay. So that's how we use what's called scientific notation, which I think we'll talk about a little later. But if we had something like this, times 3.73 times 10 to the 5th, 10 to the 5th is just telling you how many times you're multiplying by 10. So we're multiplying by 10 5 times, which means we should move the decimal over 5 times, right? 3.73. So we'd want to throw in some zeros here to make sure we could do that. 1, 2, 3, 4, 5. Okay. So we get 373,000. And then you don't have to put the decimal at the end. But if you want, right, 0.0, same thing. Okay. So that's a little trick that you can use to make it easier. Similarly, with dividing by 10, you go to the left. Okay. So 373 divided by 10. Well, the decimal is assumed to be at the end of the number if we don't have one. So you just move it to the left once. So this would be 37.3. Okay. Okay, like I said, we'll talk more in depth about decimal multiplication and division next time. This was really 5.3 as well. So let me just throw that in there in case you're keeping up in the book. So that's going to do it for today. Next time, like I said, we'll go through the addition, subtraction, multiplication, and division with decimals, and then maybe some equations with decimals. And then at the end of this chapter, we have some applications, because a lot of applications, when you're doing them, decimals come up, so we've been kind of saving them for now. Okay. All right, so thank you for watching today, and I will see you next time.